Hello children, welcome to digital class. I am sure you all are enthusiastic to learn new concepts in mathematics. Today we will be learning a few more concepts related to quadratic equation which we have learnt in our previous class. But before that, let us quickly recall our knowledge about quadratic equations. A quadratic equation in the variable x is a second degree equation of the form ax square plus bx plus c is equal to 0, where a is not equal to 0 and a, b, c are real numbers. And we have discussed why a should not be equal to 0, because if a is 0, then x square becomes 0 and the quadratic equation reduces to linear equation. And we also learnt that if x is equal to alpha is a solution or root of the quadratic equation only if alpha satisfies the quadratic equation. Today we will be learning how to find the solution of a quadratic equation by completing the square. Now let us consider an equation x square plus 4x minus 4 is equal to 0. By factorization method, we need two factors p and q such that p plus q is equal to 4 and p into q is equal to minus 4, which means the sum of the two factors must be equal to 4 and the product of these two factors must be equal to minus 4. But we observe that we have no integers p and q satisfying the above equation. So, how do we find the solution? Now, we introduce the method of completing the square. So, basically the idea behind the method is to adjust the left hand side of the equation so that it becomes a perfect square of the first degree polynomial and the RHS without x term. Now, let us get back to our equation, which is x square plus 4x minus 4 is equal to 0. Now, we need factors p and q such that their sum is equal to 4 and their product is equal to minus 4. So, what am I doing here? I am transposing this minus 4 from left hand side to right hand side. So, I get an equation x square plus 4x is equal to 4. Now, I try to rewrite the equation in the form of x square plus 2 into x into 2 is equal to 4. Now, if you can relate children, this looks like a square plus 2ab. This looks like a square plus 2ab. Now, we know the formula a square plus 2ab plus b square. So, if we add b square, it becomes a square plus 2ab plus b square, which is a perfect square. So, let us add b square is equal to 2 square, which is equal to 4 on both sides. So, coming back to our equation, x square plus 2 into x into 2 plus 2 square is equal to 4 plus 4. We get x plus 2 whole square, which is equal to 8. Why did we get here x plus 2 whole square? Because we know a square plus 2ab plus b square is equal to a plus b whole square. We are relating the identity, algebraic identity to the existing left hand side of the equation. So, x plus 2 whole square is equal to 8, which implies x plus 2 is equal to plus or minus under root 8. To remove the square here, we are taking square root for the complete equation, and that is how we get x plus 2 is equal to plus or minus under root 8. So, this implies x can be equal to minus 2 plus or minus 2 root 2. We know under root 8 is equal to 2 root 2, and after transposing plus 2 to RHS, I get minus 2. So, I get x value as minus 2 plus or minus 2 root 2. Therefore, we can say that the roots of x are minus 2 plus 2 root 2 and minus 2 minus 2 root 2. Now, let us see how to find the roots of the quadratic equation using a formula. If b square minus 4ac is greater than or equal to 0, then the roots of a quadratic equation ax square plus bx plus c is equal to 0 is given by minus b plus or minus under root b square minus 4ac by 2a. I repeat the formula, minus b plus or minus under root b square minus 4ac by 2a. This formula is known as quadratic formula. Now, let us try how to use this formula in the given equation. We are given an equation x plus 1 by x is equal to 3, where x is not equal to 0. So, to remove the x in the denominator part of this fraction, let us multiply both sides of the equation by x. Then we get x square plus 1 is equal to 3x. If I am multiplying the complete equation with x, I get x square plus 1 is equal to 3x, which implies I get x square minus 3x plus 1 is equal to 0 after I transpose this 3x from RHS to LHS. Let us compare this equation x square minus 3x plus 1 is equal to 0 with the standard form of a quadratic equation. So, I get a value as 1, b value as minus 3 and c value as 1. Now, let us substitute in b square minus 4ac. I get b square as minus 3 whole square, which is 9, and 4ac as 4 into a, which is 1, into c, which is 1 again. So, I get 4ac value as 4, and 9 minus 4 gives me 5, which is a positive number, therefore, it is greater than 0. So, I can use the formula to find the roots, and we have learnt that the formula to find the roots is minus b plus or minus under root b square minus 4ac by 2a. Therefore, we get x is equal to 3 plus or minus under root 3 by 2. Now, how did I get 3 here? Minus b, which means minus of minus 3 gives me plus 3, plus or minus under root, what is my b square minus 4ac value? 5. So, under root 5 by 2, which means I get two values for x, which are x is equal to 3 plus root 5 by 2 and x is equal to 3 minus root 5 by 2. So, we can say these are the roots of x plus 1 by x is equal to 3. Now, look at the situation, children. You can see the train moving there. Okay. Let us see the situation. A train travels 360 kilometers at a uniform speed. If the speed had been 5 kilometers per hour more, it would have taken 1 hour less for the same journey. Find the speed of the train. So, from the given data, let us see how we can find the speed of the train. There can be two cases possible. When case 1, when the train is travelling with a uniform speed, s, let me consider it as x kilometers per hour, and the distance given to us is 360 kilometers, and we know time t1 is equal to distance by speed, which is equal to 360 by x hours. Now, in the question it is given if the speed has been increased by 5 kilometers per hour more. So, that comes for case 2. Now, our speed becomes s is equal to x plus 5 kilometers per hour, but the distance remains same, which is d, that is equal to 360 kilometers. So, now our time t2 can be taken as d by s, which is equal to 360 by x plus 5 hours. In the question it is given the train would have reached 1 hour before. So, the difference between the time would be t1 minus t2, which is equal to 1. Let us substitute the values of the t1 and t2 in the respective places. Now, t1 is 360 by x and t2 is 360 by x plus 5. So, 360 by x minus 360 by x plus 5 is equal to 1. When we take LCM, we get 360x plus 1800 minus 360x by x into x plus 5. Now, how did we get this? I am cross multiplying the terms. 360 into x plus 5 gives me 360x plus 1800 minus 360 into x, which is 360x, by x into x plus 5, which is x square plus 5x, but this is equal to 1. Now, when you look at the numerator part of the left hand side, we can see 360x plus 360x and minus 360x are present there, which can be cancelled. So, I am left with only 1800 in the numerator part and I transpose this denominator to the right hand side by multiplying with 1. X into x gives me x square and x into 5 gives me 5x. So, let us rearrange this equation x square plus 5x minus 1800. I transposed this 1800 to the other side and that is how I got the equation as x square plus 5x minus 1800 is equal to 0. Now, we are trying to write this 5x by splitting the middle term which we have learnt in our previous lesson. Okay. So, I can write this 5x as 45x minus 40x, which means 45 into 40 gives me 1800 and 45 minus 40 gives me 5x. So, x square plus 45x minus 40x minus 1800 is equal to 0. Now, let us take the common in both the terms here. I take x as common. So, I get x into x plus 45 and I take minus common here and minus 40 into x plus 45 is equal to 0. We observe x plus 45 is present in both the terms. So, let us take this as common. I get x plus 45 into x minus 40 is equal to 0. Just remember children, when the product of two terms is equal to 0, then each one must be 0 or either of one must be 0. That is, if AB is equal to 0, then A must be equal to 0 or B must be equal to 0 or both A and B must be equal to 0. So, our x plus 45 is equal to 0 or x minus 40 is equal to 0. So, let us transpose the terms respectively. When I shift this plus 45 to the other side, I get x value as minus 45 and when I am transposing this minus 40 to the other side, I get plus 40. So, I get two values for x which is minus 45 or 40. Now, we are trying to find the speed of the train and we know that speed cannot be negative. So, we cannot consider the value of minus 45 for x. So, the speed of the train should be 40 kilometers per hour. Now, I hope you understood how we relate the daily life situations to quadratic equations. Now, let us learn how to find the nature of roots. Roots of a quadratic equation ax square plus bx plus c are given by x is equal to minus b plus or minus under root b square minus 4ac by 2a. This is what you have just learnt as quadratic formula. But we can say that roots of a quadratic equation are those points where the curve cuts the x axis. So, when we are representing the solution graphically, we observe the points which meet the x axis will only be called as roots of the quadratic equation. Now, let us see the cases related to it. In case 1, when b square minus 4ac is greater than 0, then we get two distinct real roots. What do we get? We get two distinct means different, two distinct real roots, and how the roots would be minus b plus or minus under root b square minus 4ac by 2a and minus b minus under root b square minus 4ac by 2a. And how the graphs would look like? In this manner. When you look at the graphs, you can see that the curve is intersecting the x axis at 2 points, one over here and the other point over here. So, these points where the curve is meeting the x axis are called as the roots of the quadratic equation. There could be the possible, these could be the possible cases. Now, let us look at the other case. If b square minus 4ac is equal to 0, what happens if b square minus 4ac is equal to 0? Then x would become minus b by 2a. So, our roots would be minus b by 2a and minus b by 2a. So, we are getting two roots which are real and equal. Observe the roots children. Here x is equal to minus b by 2a and minus b by 2a. We are getting two real and equal roots. And how would the graph look like? Yes, when you observe the graph, you can see that they are meeting the x axis at only one point, and that is why we are getting two equal roots. When you observe, see here also you can see the curve is meeting the x axis at only one point. Now, let us look at the third case, which is b square minus 4ac is less than 0. when b square minus 4ac is less than 0, the value is negative. So, there are no real roots. So, we can say that the roots are imaginary. Now, let us see how the graph looks like. Look at the graphs, children. When you look at the curves, you observe that they are not meeting the x axis at all. You can see they are not meeting the x axis at all in any of the graphs. So, we can say that the roots are imaginary. Thus, we can say b square minus 4ac determines whether the quadratic equation ax square plus bx plus c is equal to 0, where a is not equal to 0 has real roots or not. Thus, we can say b square minus 4ac is called the discriminant of the quadratic equation. So, we can say if b square minus 4ac is greater than 0, we will get two distinct real roots. If b square minus 4ac is equal to 0, we get two real equal roots, and if b square minus 4ac is less than 0, we get no real roots, but we get imaginary roots. Now, let us learn how to find the nature of the roots of the following quadratic equations. Look at the equation given there. 2x square minus 3x plus 5 is equal to 0. The given equation is in the form ax square plus bx plus c is equal to 0, where a is equal to 2, b is equal to minus 3 and c is equal to 5. When we compare the given equation with ax square plus bx plus c is equal to 0, we get a as 2, b as minus 3 and c as 5. So, let us find b square minus 4ac value. When we are substituting the respective values, we get minus 3 whole square minus 4 into 2 into 5, which is our 4ac value. Then, we know minus 3 whole square is 9 and 4 into 2 8, 8 5s are 40. So, we get 9 minus 40, which is minus 31 less than 0, and we know all the negative numbers are less than 0. So, the given equation has no real roots. Now, let us observe another case. We are given an equation 2x square minus 6x plus 3 is equal to 0. The given equation is in the form ax square plus bx plus c is equal to 0, where a is equal to 2, b is equal to minus 6 and c is equal to 3. Substituting these values in b square minus 4ac, what do we get, children? We get minus 6 whole square minus 4 into 2 into 3. Our minus 6 whole square is b square value and 4ac is 4 into 2 into 3. We know minus 6 whole square is 36 and 4 into 2 into 3 is 24. So, 36 minus 24 gives us 12, which is greater than 0. So, the given equation has distinct real roots. Now, let us learn how to find the value of k for the following quadratic equation when it has two equal roots, where it is given that they have two equal roots. Now, what is the equation given to us? Kx into x minus 2 plus 6 is equal to 0. Kx into x minus 2 plus 6 is equal to 0. So, first we have to open the brackets by multiplying with kx. What do I get here? Kx square minus 2kx plus 6 is equal to 0. Now, the equation is in the form of ax square plus bx plus c is equal to 0, where a is k, b is minus 2k and c is 6. Substituting these values in b square minus 4ac, I get minus 2k whole square minus 4 into k into 6, which is equal to 4k square minus 24k. But what is given to us? It is given that the quadratic equation has equal roots. So, we have to equate this b square minus 4ac to 0. So, b square minus 4ac is equal to 0, which means 4k square minus 24k is equal to 0. Let us take 4k common in both the terms. I get 4k into k minus 6 is equal to 0. Again, we apply the same concept that if the terms a and b, their product is 0, then a must be equal to 0 or b must be equal to 0. So, 4k is equal to 0 or k minus 6 is equal to 0. when 4k is equal to 0, k is equal to 0, or when k minus 6 is equal to 0, k is equal to 6. Thus, 0 or 6 are the values of k satisfying the given quadratic equation. Okay children, let us try this. Is it possible to design a rectangular park of perimeter 80 meters and area 400 meters square? If so, find its length and breadth. Now, let us imagine the park would be something like this. Very interesting, right? We all love going to parks. So, what do? I consider the length as x meters and breadth as y meters. What is the perimeter given to us? It is given to us as 80 meters and area of the park should be 400 meters square. Therefore, perimeter given is 80 meters, which means we know the formula to find the perimeter as 2 times of x plus y. 2 times of length plus breadth, we have taken length as x and breadth as y. So, 2 times of x plus y is equal to 80. When I transpose this 2, which is multiplied onto the left hand side to the other side, it divides the 80 which is on the right hand side. So, I get x plus y value as 80 by 2, which is 40. So, I get x plus y value as 40. I am transposing this x to the other side and considering this equation y is equal to 40 minus x as 1. Also, it is given to us as area is equal to 400, which means x into y should be equal to 400. I consider this equation as 2. Substituting 1 and 2, x into y is equal to 400. Instead of y, I substitute 40 minus x from my equation 1. Then I open up the brackets by multiplying with x. X into 40 gives me 40x and x into x gives me x square with a minus. So, I get 40x minus x square, which is equal to 400. Let us rearrange all the terms. Then I get minus x square plus 40x minus 400 is equal to 0. I have transposed this plus 400 to the other side. I get minus 400 is equal to 0. So, my equation becomes now x square minus 40x plus 400 is equal to 0, because I have multiplied this complete equation with minus to remove the negative sign of x square. Now, I get a standard form of the quadratic equation. Here a is equal to 1, b is equal to minus 40 and c is equal to 400. Substituting in the quadratic formula minus b plus or minus under root b square minus 4ac by 2a, I get x is equal to minus of minus 40 plus or minus under root minus 40 whole square minus 4 into 1 into 400 by 2 into 1. So, I get x as 40 plus or minus under root 1600 minus 1600, and we all know 1600 minus 1600 is 0. So, I get 40 plus or minus under root 0 by 2, which is 40 by 2, and 40 by 2 is 20 meters. So, I get my x value as 20 meters. But we know y is equal to 40 minus x. So, our y value also will be 40 minus 20, which is 20 meters. Therefore, we can say it is possible to design the park of length 20 meters and breadth 20 meters. Okay children, let us quickly recap what all we learnt today in our class. Quadratic formula to find roots is minus b plus or minus under root b square minus 4ac by 2a. So, what is the formula to find the roots? It is minus b plus or minus under root b square minus 4ac by 2a. And roots of a quadratic equation are those points where the curve cuts the x axis. So, roots of a quadratic equation are those points where the curve cuts the x axis. If b square minus 4ac is equal to 0, then the quadratic equation has two equal roots. If b square minus 4ac is equal to 0, then the quadratic equation has two equal roots. For an equation like 2x square minus 4x plus 3 is equal to 0, the roots are not real, because when we substitute the a, b, c values in b square minus 4ac, we get a negative value, and we know any discriminant getting negative value will have no real roots. That is all for today, children. Hope you have understood the concepts related to quadratic equations. For better understanding of concepts, solve the worksheets. Please visit the official website of SCERT. Okay, children, I hope you all understood the concepts related to quadratic equations, what all we learnt today. Let us all meet in the next class with a new lesson. Thank you. Happy learning.